So, we all think of AI agents as these incredibly brilliant minds, right? But have you ever stopped to wonder how they actually do things in the real world? How do they check the weather or search through a huge code base? Well, they use a standard method, but what if that entire method is just wrong? What if there's a much, much better way? Yeah, that's a pretty bold statement to kick things off with. It cuts right to the chase, suggesting that the whole foundation for how we give AI tools might be fundamentally flawed. So what on earth is this MCP, and how have we all been getting it wrong? Okay, so the standard way this works is something called tool calling. This is basically how developers give an AI powers beyond just having a conversation. It's the mechanism that lets an AI reach out and actually interact with other programs and data. And it's all built on a protocol that's supposed to make everything standardized and simple. And that protocol is MCP, the Model Context Protocol. You can think of it like a universal translator. It's a rulebook that lets any AI talk to any tool, no matter who made them. It's the framework that has seriously expanded what AI agents are capable of. But how it actually works? Well, it's a little clumsy. See, this whole process isn't just one clean action. It's a loop, a constant back and forth. The AI decides it needs a tool. Then everything has to stop. The system pauses the AI, goes and calls the tool, waits for the result, then feeds that result back to the AI. And if another step is needed, we do the whole dance all over again. It's a huge waste of time, energy, and tokens. This analogy just hits the nail on the head. LLMs were never really built for this kind of rigid, structured tool calling. It's like a foreign language to them. Sure, you can teach them, but as the source material points out, it's just not going to be his best work. It's not that they're naturally good at. So, okay, beyond the analogy, what's technically wrong here? Why is this approach such a bottleneck, and why does it limit what the AI can do? Well, the answer is all about how these models were trained in the first place. And this is the absolute crucial difference. On one hand, you have large language models that have been trained on basically all of the internet's open source code. They are true masters of programming languages. But on the other hand, you have tool calling. It's an artificial concept they've only seen in these tiny synthetic training sets. We're basically asking them to speak this clunky, made-up dialect when they're already fluent in a much richer, more powerful language. And that brings us to the breakthrough. The big idea? Code mode. Instead of forcing the AI to speak that clunky artificial language of tool calls, why not just let it use its native tongue? Why not let it do what it does best and just write code to get the job done? Now, this process is so much more elegant. First, the system just translates all the available tools into a standard programming interface, in this case, TypeScript. The AI sees this, it recognizes it, and instead of that slow loop, it just writes one single script to get the job done. You execute that script once, and you get your final answer. It's direct, it's fast, and it's so much more efficient. This right here is what the AI actually sees. It's not some abstract tool anymore. It's a clean, well-documented TypeScript API, just like the millions of examples it was trained on. It knows exactly what to do with this. And that simple translation changes absolutely everything. Okay, I know what you're thinking. This sounds great, but it brings up a massive question. If the AI is just writing code on the fly, you need a place to run it. And that place has to be incredibly fast, completely secure so it can't do anything malicious, and cheap enough to use for every single tiny task. That sounds like a really tall order. The answer isn't traditional servers or containers. Nope. The secret ingredient, the magic that makes all of this possible, is a technology called V8 isolates. These are super lightweight, super secure sandboxes that provide the perfect environment for running AI-generated code. This image just captures the difference perfectly. On the left, you've got your traditional containers. They're powerful, sure, but they're heavyweight, they're slow to start up, and they're memory hogs. And on the right, you have VA isolates, the complete opposite. They are unbelievably lightweight, start up almost instantly, and use a tiny amount of memory. And let's put a number on that instant startup. We're talking less than 5 milliseconds. That is so ridiculously fast that you don't even need to reuse them. For every single piece of code the AI writes, you can spin up a brand new, perfectly clean, totally secure sandbox, run the code, and then just throw it all away. The overhead is practically nothing. This platform's whole design is just uniquely perfect for this job. The sandboxes are disposable, like we said. They're also completely isolated by default, no network access at all. So how do they actually use the tools? Well, that's where this third key feature comes in. something called bindings. Bindings are an absolute game changer for security. Instead of giving the code general internet access and a secret API key, you give it a direct, pre-authorized connection only to the specific tool it's allowed to use. It's like giving someone a key that only opens one specific door instead of a master key to the entire building.
And this is the punchline. Because the authorization is handled by the binding itself, the AI's code never needs to see or even know about your secret API keys or tokens. This solves one of the biggest security nightmares with AI-generated code in a single elegant move. The keys just can't be leaked, period.
So what does all of this mean when you put it together? We've moved from a clunky, unnatural process to one that's fluid, efficient, and incredibly secure. This isn't just a small improvement, it's a fundamental shift in how we empower our AI agents. So to just lay it all out, code mode is way faster because it's a single execution. It handles complexity way better because the AI is fluent in code. It's fundamentally more secure because of the bindings model. And it's just a more natural task for the LLM. It's a clear win, right across the board. So the ultimate takeaway is this. By letting AIs do what they do best, write code, and giving them a safe, instant place to run it, we unlock a whole new generation of agents. They can tackle more complex problems, they can string together more sophisticated actions, and they can do it all in a way that's secure from the ground up. This really just opens up your imagination, doesn't it? By taking away the old bottlenecks of speed and security, we've basically let a powerful intelligence work in its own native language. The ceiling for what's possible has just been raised dramatically. So the real question is no longer how AI will perform tasks, but what are the truly massive problems we're going to ask it to solve next?